In this lesson, we'll be talking about refraction samples. Obviously, this has everything to do with see-through and refractive surfaces like glass and water. So a camera ray hits a surface that has a shader with refractive qualities that has a roughness bigger than 0. Refraction rays will be generated in random directions and propagated through the object. The number of those rays can be controlled using refraction samples. So as you increase your refraction samples, you are increasing the number of generated rays at the hit point and at the same time increasing the quality of the indirect refractions and reducing the amount of noise from the indirect refractive areas. Now here is the scene that we have. The same setup from the previous lesson. I have a new object in the scene, which is this glass and our sphere and abstract 3D object, which have two color diffused shader. Also, this is the material that I have applied to my glass. Let me just open it up. As you can see, its diffuse weight is 0. If we take a look at the specular section, you see the weight is 1 and we have some roughness. This way our glass would be reflective a bit. And in the refraction section, the weight is 1. The IOR or index of refraction is 1.51, which is a standard value for most household glasses. Finally, I have some roughness about 0.25, so the glass would be a frosted glass, not a perfectly clear glass. As you can see, I've also changed some of the other options to make a nice beautiful glass. You can check out the material if you wanted to, but we're going to be going through this refraction and the whole shader system and standard shader and the other shaders in Arnold in our future lessons in a lot of detail. So no worries, just go with this. You don't need to know how to create refractive materials right now. Just you need to understand that that is a refractive see-through material. Also, if you take a look at the glass object that I have here, I have applied an Arnold parameter tag and disabled the opaque option. You should do that if you want to render a refractive surface correctly. We're going to be talking about Arnold parameter tag in quite a lot of detail later on. Also, the samples for the two area lights that I have in the scene are 4 in this scene. Now, so let's open up the render settings, and with default setting, if I open up my picture viewer, this is the render that we are gonna get. So to make the process a bit quicker, I show you the renders in the picture viewer. So let's open it up. There we go. Now, as you can see, we have this beautiful render. Now let's open up our render setting window and let's decrease camera, diffuse, and glossy samples to 1. SSS and volume samples to 0, and let's enable the IPR. Let's just wait a bit until we have a clear image in our IPR. As you can see, we have a very noisy result. As soon as I zero out my refraction samples, you can see our glass has no refractive quality anymore. We just see some specular reflections. That's because, as I mentioned, the refraction that we have on this glass is rough. If I open the material for this glass and come down to the refraction section and zero out the roughness value, now we have a clear glass. If you take a look at the IPR, now we have a perfect see-through glass. But as soon as we introduce some roughness and therefore generating secondary refraction rays, we need to increase the refraction sample in order to see the glass correctly. So let's set the roughness value to be 0.25 again, and as you can see, the glass went black. Now let's increase refraction samples to 1 and stop the IPR. If we render this scene with the current setting that we have, the result would be like this picture in the picture viewer. There you go. As you can see, the glass and the rest of the scene is very noisy. Now let's increase the refraction samples to about 4. And if we take a look at the render with the current setting, you can see we have increased the quality of our glass and finally we can increase the camera samples to something like 4. Diffuse and glossy samples can be about 2. And if I render these, the result would be like this image. As you can see, the image is perfectly clear, and because we have increased our camera samples as well, the number of refraction samples are much more compared to the previous render. So remember, the input of refraction samples squared multiplied by the camera samples squared is the actual number of refraction samples. So maybe we can decrease our refraction samples a bit and still have a noise-free render. So I'll let you discover that possibility on your own time. When you finished watching this lesson, you can go ahead and see if you, because now we have our camera sample increased, so obviously we increase our refraction samples and all the other samples in the scene. So now we can go ahead and decrease our refraction samples maybe to 3 and see if the render is going to be the same beautiful noise-free render, but with less amount of time spent on rendering. So you can go ahead and explore those options and see which is going to yield the best render with the best render time. So basically that's about refraction samples. So we still have SSS samples and volume samples obviously to discuss. We covered them later on in the course when we discuss scene shaders and volumetrics. And from the next lesson we start talking about array depth. See you there.